Okay, for people joining this live stream, this is a meeting about Wolfram Language features. I think we just wrapped up version 12, so these features will be mostly going into subsequent versions. Let's get started here. So we're talking about random instance. So this is trying to normalize the behavior of our various random star type functions. Okay, great. All of those I know about. They all seem just fine.
Right. So we have, so I perhaps subdivided a bit much, but we have sort of the things I call basic random and then the specialized basic random, which behave essentially the same way, but they return things which are a bit more interesting than just numbers. So
okay,
random color, random geoposition.
Random variate, by the way, when it has a learned distribution that came from the machine learning system, will also return something less trivial, right? I think random variate is going to work on learned distribution. So I'll give you a random cat picture or something. Yeah?
I am not aware of that.
Okay, well, I think that's what's going to happen. But anyway, okay. So, okay, well, so wait a minute. Another example of randomness is the random instance.
Well, I claim that random instance doesn't fit in really, and we need to think about this. So, right. So then we have the things which are clearly just using randomness. So that's things like, I don't know why that section is closed there, but if you look at things that the things that use randomness, right? So that's things like feature space plot and.
It doesn't, well, it uses randomness, except that it's a fixed randomness, right? I mean, it doesn't, the default is to use a fixed random seed.
Correct.
Sure.
Okay.
But the point is that they're using randomness not for randomness's sake. Unlike...
Okay, so it's all right. Can we just cut to the chase here? What is the issue? That there's a inconsistency between the way that randomness is accessed in these functions, or what?
Well, if the point is, I don't think random instance is properly thought out. Okay, so we have right. So if we look at the basic random things, they don't take random seeding options and they return random things. Then we have.
Okay, so wait a minute. These things are externally seeded. So, for example, if I were to do random this, and I were to say seed random 1, 2, 3, 4, random image.
Right.
And this, let's do it in a case where I can tell what's going on a little bit more. Whoops.
Try 5, just 5. The list 5. Sorry, the number 5.
Okay, it's not what I wanted. I wanted a thing that would give me a 5 by 5 array. So maybe I say 5, 10 by 10. Okay, so now if I do that again, I get the same thing, right?
Right.
So these are externally seeded.
Right.
Correct? And these things don't have an internal seeding option. Is that correct?
Correct.
Okay. And wow. Okay. So it's a little funky because this is using.
Wait. Oh, random graph takes.
No, it's just.
Okay. To seed random.
Yeah,
yes.
It's just taking seed random. Right. Okay. What is random geo position?
So I don't know why it's showing up in 2 contexts there, but it's right.
So random geo position takes a region and a number of points.
Oh yeah, right. It's like random point, but it's
exactly.
Okay, but so why is it in red?
Because apparently you have another random geo position in a different context for some reason.
Well, that should be tracked down. I mean, let's
It's not read in my.
Yeah. Okay.
Mine.
How do you find out what's in what the different context version? Oh, look, it's in
Names.
prototypes.
Yeah.
It's in prototypes backtick.
Is that our nodes thing?
I have no idea. I mean, our node has a thing called something like that. Okay, well that has to be tracked down. So can somebody?
Yeah,
let's
I
see
can do that.
Okay, and it either is a Roger issue or it's a build issue of some kind.
Mm-hmm.
Well,
Okay.
I think it's that you have prototypes installed and loaded.
Yeah, but for some reason it seems to still work. This is very, very confusing. Okay, so if I say here, oops. So now does random geoposition also not have? It's also externally seeded. Is that correct?
Correct.
Okay, so I mean, one of the things you're going to point out here is that all these random functions have external seeding.
Yep.
Okay.
Well, and not only do they have external seeding, but they effectively affect the seed for subsequent calls.
Exactly. Yes. Okay. All right. So control of randomness, block random seeding. Okay. So random seeding is localized to that function, correct?
Correct.
And so, I mean, one thing that I would like to offer as a possibility, right, is that all the random functions could take a random seeding option, which would be essentially a shorthand for block random, seed random, and unblock, so to speak. And that would be a convenient way. I mean, if we're comparing the code of random image blah blah blah, 5 10 10. I don't even know what the 5 means. What does that 5 mean?
Oh, that must be like the maximum value or something, right?
Okay, so we have a choice between that and block random of seed random, blah blah blah, semicolon this, and I would argue that form is a nice, sort of functional type form.
Right. Although that the second form is more powerful.
Absolutely, much more powerful. The first form is purely a shorthand that would basically allow you. It's a shorthand for a localized random seeding within this function. Okay, so let's keep going here.
So, well, let's get some opinions on that before.
Well, I think that the question whether we do that is partly related to what I think your complaint about random instances, which I agree is not consistent right now. So let's okay, so random entity. Okay, so feature space plot. So one of the points is things like feature space plot their randomness can never leak out. Right?
Well, it can if you specify the appropriate random seeding value.
Is that true? With random seeding automatic, it leaks out? I don't think so. Does it change the state? Does it?
Yes.
It's not obviously correct to do that.
I
mean, to me, random seeding automatic, it would make more sense. Well, okay, so here's an argument. Random seeding automatic could do a reseeding from the randomness source, okay, which could be different.
Which I believe is inherited.
Oh, that's inherited. Okay, I was going to say inherited would be take it from the ambient random stream, and automatic would mean reseed.
I think that's what it is. It's what it says in documentation of random seeding.
Okay, so it is exactly what I just said. So we just reinvented what I thought it should be.
Automatic says automatically reseed every time.
Okay, great. That's exactly what I would have expected. Right.
That should not leak out.
No, this one, use externally seeded random numbers, does leak. Right?
No, I don't think it should leak.
But how can it not leak? It'll give the same answer every time. If you run the same function 3 times with inherited, it will then give the same answer every time.
Right. So look.
That's what's only if your random state is at the same position.
I mean, look at the basic example. We call it twice with random seeding goes to automatic, and clearly it's affected the random state. Otherwise, those would have.
No, you're wrong. You're wrong. It's reseeding. It's like doing a seed random open close each time. Okay, and in fact, this should give an example, and let's do it for ourselves.
So why are those two different?
Because
Why
it's
are 3 and 4 different?
reseeding. It's reseeding. Okay, let me show you what I think these are doing. Okay, so that's that. Okay, so what I claim this is doing is the equivalent in here of saying block random, okay, of, let me show you, block random of seed random open close, which seeds from the entropy source. You see what I'm saying? It reseeds every time. So let's see whether I'm right in my claim that if I say inherited here, okay, so I'm gonna try something which I claim will work. Okay, so let's say I say random seed, doesn't matter, one something. Okay, whoops, seed random rather. Okay, of that. By the way, it's not totally obvious that returning null is the right thing to do there, but that's a different issue. Okay, find instance. Okay, this. Oh.
Yeah, see, that's exactly what I was saying.
Totally weird.
Well, now put a random.
That's intentional, Stephen. That's how we designed it.
Okay.
It takes so whatever your randomness, so you could change that random seed and it would give a different value, but it just inherits a random state from outside, whatever that random state from outside happens to be. But it always localizes. So random seeding always localizes, which is why your argument about putting in these other functions as a local thing is a reasonable thing.
Yeah, okay, fair enough. And if I now say here, random integer, blah, 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 and then I do it again, I'll get a different answer.
Bingo.
Yeah, okay, that makes sense. That's pretty decent.
So what's the difference between inherited and automatic, Rob?
Inherited, you can set with seed random. Automatic, there's no way you can set it.
Right. Automatic just basically randomly selects a seed from the current time and various other system parameters.
Could we please add some examples to oh, I see, you give it in scope. Okay, fine. Okay, all right, so let's keep going here. Okay, so random entity.
Right. So, well, before we get to random entity, because that's more of an implementation thing. So, random instance.
Mm-hmm.
Right. So, first of all, we have this very general sounding thing, which at the moment understands exactly one head.
Yeah, we know that. Right. That's
well, the question is, so question A is, what other things do we see taking this? I mean, just really feels more like your what I was calling the specialized basic randomness.
okay, so I think what we imagine is find instance getting a,
find instance already takes a random seeding option.
I understand that.
Yeah, and I thought when I heard about this meeting that random instance was going to be some specialized version of find instance.
Well, is Michael here?
Ian is here. At least he was.
Yeah.
I think Michael is the more relevant one if he could be found. I mean, he's the one who had an opinion about what this should do.
Well, if
I'll try to find him.
Okay. Right, but the point is, I mean, right. So Michael was very insistent that the default should be automatic rather than 1, 2, 3, 4 for the random seeding option.
For random instance?
Yes. And in fact, that's the documented default.
I think that's weird.
Which is problem 1. Problem 2 is, what else do we think can go inside of here?
Yeah, okay, I understand. I think that's, okay, so this, okay. What is this? This is a thing. See, it's an interesting question, right? Because, I mean, these are things, which are defined by constraints. What should go inside here? It's
right. So let me Etienne. So the neural network context had a random instance function, which I discovered once I merged this and needed to resolve the conflict. So what does that do? And is it more like this random instance, or is it more like the other guys?
Actually, I don't know.
Oh, okay.
You mean the neural network framework you said?
Yes.
No, I don't know what you're talking about.
Ah, okay.
all right. Look, I think we need to find Michael, because we discussed a variety of different cases of this, but let's hear about what the issue with random entity is.
Right. So you can see it's not respecting block random. That should give the same country 10 times. And
do we understand what the issue is?
I think so. Jeremy can undoubtedly explain it better than I can, but I think it has to do with at least part of random entity has to run on the server, and the server doesn't know what the random state of the client is. So,
right, so we're going to have to tell it.
Well, it's more than that, because it's not all Wolfram language code on the server, and so there is no. I'm saying all of this, and I think right. I think we did do something so that it's seeded, so that I think what Itai is saying is obsolete information. Actually, I think it is actually possible to pass in the seeding. And get it to be reproducible, but it's not, it's not a one-to-one correspondence just because of all those implementation details.
Right, but you're saying, I mean, although this could be considered a bug right now, this is a fixable bug. I mean, you're saying if I say block random, and I say it around this, for example. Oh, for goodness sake. Block random, I want to say table. Yeah, okay, so it does the same thing every time there. Okay, so that is a bug, basically.
Right.
Of unknown complexity to fix in random entity.
Right.
Yeah, and my recollection is that we did add support for that on the alpha server. And so maybe it just needs to be hooked up to entity value.
Okay.
Okay. Yep.
Yeah, I mean, like I said, this was really an implementation detail. It's just I made a complete list of every random function I could find. So.
Okay. All right. So let's boil this discussion down. So first issue is Itai is complaining about the generality of the name find instance.
Random instance.
Sorry, random instance. And second point is there's the possibility of adding random seeding options to all of the random functions. I support that second thing. I think it's a nice, consistent thing to do. And the default value for most functions, well, what is the default value for most functions? The default value is yet a value we don't have right now, which is neither automatic. They neither reseed. See what I'm saying?
Right. So that's sort of.
Okay. So it's a beyond inherited. I mean, maybe what it should say is random seeding arrow none.
That was my thought.
That means it's a pass-through business.
And do we see allowing that also in the higher level functions?
Yeah, that's a good question. I would say yes, if we can do it reasonably easily.
I mean, the way that things should do it is just by using block random.
Yes.
Right. Well, except we need the opposite, right? To implement none, we need unblock random or something.
Right.
No, it's a little more complicated how to do that. I mean, basically.
And I don't think it's the world's most important thing. I don't think on day one find instance needs to support random seeding arrow none. I just don't think it's that important. I don't think anybody cares. Okay. Okay, so let's look. It's not the most urgent thing, but I think that's a nice consistency thing to add. Okay, so let's come back to the question of random instance, and I just don't think we can do that without Michael. So we may have to put that off. Now, obviously, that's a version 12 feature, so we need to be mindful of it.
I have a suggestion here. So perhaps random instance should be the version of find instance with a different random seeding value.
Well, yes, it could be. It could be.
And that's it. Because in a sense, a geometric scene is like a set of equations. It's just a set of equations for geometric objects. But we can visualize it as a set of equations as we would feed to find instance.
Right. Well, so that raises the possibility that instead of random instance, we call it find instance. Except that, and right now with find instance, that does.
Well, find instance could always return the same thing because find instance has a definite random seeding.
No, but does it return the same thing?
Yeah. So by default, yes. And
Okay, well, we can't change that.
And there are certain cases, and if it happens to be able to give an instance without invoking randomness, then the random seeding option is ignored. But the default value of the random seeding is 1, 2, 3, 4. So by default.
Yeah, I understand. Right. So what Jose is saying is we could introduce a random instance, which in the case of things like this is uninterestingly different from find instance. But in the case of this, so what's happened here is that whereas here that variable is an explicit find instance, variable, here that's been implicitly put in this geometric scene. Am I making sense?
Yes, but perhaps in the future random instance there will have cases in which it needs a second argument.
Well, I agree.
Kind of like I like Jose's idea of just making this find instance and.
Well, no, he's not saying that. He's saying there should be a random instance which is basically the same as find instance, but has different random seeding option. Right? That's what you're saying, Jose, correct?
Right. And then we can take the idea backwards and make find instance work on the things that random instance currently.
See, what I think would be a better idea is just don't have random instance and call this find instance and just it's another set of things for which find instance works.
Yes, I agree that that's not a crazy idea.
Yes,
Ian,
but
would you like to comment? Yeah, go ahead.
I must admit I didn't know that find instance was able to handle randomness before.
Yeah, I agree, which means that having two closely allied functions, find instance and random instance, seems not completely silly to me.
Right, because most find functions do not handle randomness.
Right, now one thing that's a little crazy, weird, right, is look at this argument structure. There's variables, domain, and then the number of instances.
Right.
Whereas
you can well, I don't know if you can omit vars, but you can certainly omit dom because 2 is a number is clearly distinguishable from a domain.
Well, and so is it distinguishable from vars. It's a little bit of a hack, but I mean, we could certainly have a 2-argument form of random instance. What's funny here is this is related to a bunch of things that Roger has of implicit functions, which we could imagine defining, which has this x as essentially a localized variable. See what I'm saying? I mean, so in other words, we could imagine a implicit function or something. I'm sure implicit region already does that. I'm just I'm saying x an element of reals. So I'm saying if we had something like that, and then said find instance of that. See, another thing that's very weird, okay? What is find instance of a geometric scene returning? It's another geometric scene, is that right?
Correct.
Yes.
Or a list if you give it an account.
I'm sorry, what? Or a list of geometric scenes, right?
Right.
But that's a different thing than this thing here, where we would be saying, where essentially the localized version of this would be something totally weird that says that, for example.
Mm-hmm.
Well, it depends how you look at it, because we could think that if we have find instance on a set of equations, what we return is another set of equations for
No, it's not right, because
for
the
X.
equations would just be satisfied for those x's. What we're trying to return is the instances. Okay, what's the analogy?
I see. So it will be returning the values of A, B, C, and O, the points.
Well, but it inserts them inside the geometric scene. So what's the analog of that for equations? See, what this is effectively saying is there's two things that are going on here. One is the triangle isn't an equation at all. It's just a hello, I'm here, right? But some of these other things are, I mean, that's not really an equation, although it is a mixture of an equation and a thing, because it's a circle, but it has the implicit constraint that ABC all lie on a circle.
A triangle also is like that because the solver will try to find a non-degenerate triangle.
Fair enough.
Right. And right, so circle through is sort of like the equation AO squared equals BO squared equals CO squared, right?
Sure. But I'm trying to understand that there's, in addition to the equations, which just assert true or false, geometric scene has an additional character, right? Which is that it actually represents the scene.
Right.
And I'm asking, what's the analog of that in the case of the food that a find instance usually gets fed?
It would be something like equation object, which contains the equation, comma, x goes to 3, 2 goes to... It's the equation and the solution to the equation.
Right.
Yeah. Okay, but when this gets its solution, you know...
Right. Well, it sticks, right? Look at the input form of that, right?
Of this thing here.
Yeah, it basically puts in replacement rules, just like solve might.
Yeah. What the heck is this? C of geometric quantity. What is that?
It introduced additional parameters for the center and radius of the circle through.
Wow, what is that thing?
Right, so I guess it's saying that the radius of the circle is 1.477, and
why is it making that second thing a hold form thing?
That's there's an existing issue of certain things that are auto evaluating that we're sticking in the hold form until the geometry team makes them not auto evaluate.
Okay, so listen, again, we need Michael, but I think the way we're going to go with this is we're going to have a find instance, random instance pair that we're going to support generally, and random instance is going to be happily used for this particular case of geometric scene at this time. Anybody violently object to this approach? And I think also there is a machine learning use case. I mean, I'm trying to think. I mean, again, I'm still trying to understand the nature of this thing, which is a combination of a thing and constraints on the thing. Right? I mean, it would be more like saying, constraints on a, b, x, y, x squared plus y squared equals 1, for example. That would be the analog here. And then when we say random instance of that thing, then it would become, and this is a Rob type issue, because this is also constraints x arrow 1, y arrow 1, whatever it is, x squared plus y squared equals 1. That's the direct analog of the geometric scene case. Now, is that useful? I don't think it's completely useless. I mean,
y is 0.
what's that?
I'm joking that at least one of x or y had better be 0 if we want to do it.
All right. Okay. Fine. Yes, I'm just wrong. Okay.
For example, imagine that random instance took the geometric scenes as it is right now, and then a list of 4 names, which are the new names of your points. And then in that case, it returns capital A goes to 1,2 and capital B goes to 3,2.
I see what you're saying. I see what you're saying. So in other words, if what we did here was to say, it's a little weird because I mean that what you're saying is saying find instance of this, comma. Oh, I see. So we could in principle just say ABC, for example, here, not even recording all of the points.
Right. So that's information you are interested in. If
right.
You don't provide.
And then that would give you, just like find instance does, it gives you the values.
Right.
That seems pretty reasonable. Whereas random instance, in the default case, I mean, random instance in the default case would just give you, for an equation, would just give you true. Again, I think this needs Michael.
And maybe also Adam.
Yes.
If we're talking about extending find instance, we probably want Adam around.
Yes.
Okay.
Okay. All right. Okay. So I think we have a path there. Let's talk about distance matrix.
Right. So it has some.
Is distance matrix an Etienne production?
Yes. And it has some. So if you look at Ilian and my examples, it has a couple of examples where actually I thought I knew what it was doing, but when I looked at it again today, I'm not even sure what it's doing. So maybe Etienne can explain. And
yeah, so I think the basic problem is, I mean, so it's an interpretation of the data. It's used, I mean, it has been implemented with the same interpretation of data as all the other machine learning functions, which don't know symbolic data. It's numeric, nominal, image, whatever. And some people expect distance matrix to interpret things differently. I guess distance matrix is kind of at the frontier between machine learning functions and more low-level numeric. Actually, not.
But why is it different from norm? I mean, isn't norm another thing like distance matrix?
Well, norm gives you the norm of a single thing, and distance matrix is giving you the pairwise distances.
Well, I know. But I mean,
I'll just mention that it's very unfortunate that norm evaluates for symbolic stuff.
Actually,
why?
I have the feeling that 3 type. Oh, sorry.
No, go ahead.
Go on. No, but I want.
Why? Okay, well, like in the in the optimization modeling, a common case that comes up is something like norm of a dot x minus b, where b is a vector, and when norm evaluates it, it threads incorrectly, and that's completely unrecoverable.
Okay, so what are we going to do about that?
Well, we've come up with a few workarounds.
But this is distance matrix, isn't it? Or am I confused?
Well, it depends on how it interprets the data. And so
my argument, I mean, maybe it's too late because distance matrix has been out for a while. Wouldn't it be nice if distance matrix just didn't evaluate when it had symbolic entries?
I don't think that's correct necessarily. I mean, listen, you're telling me that you want a version of norm. By the way, we've got a bunch of weird background noise here. You're telling me that I mean, okay, that ship has sailed. So let's probably, but let's look at this output. Am I correct that distance matrix is this?
Right. So, well, in some cases, right? So if you
Why
put
would
in
it not
1 and 9 and 1 and 9 for your for X and Y there, right? Then you'll get the N of 1 in Ilian's email. At least I hope you will. Beautiful.
Okay.
But
Okay.
if you, as you can see,
okay, so if I put in here 1 and X.
Yeah, it will interpret things as being nominal with distance matrix.
But
Okay, so what you're saying, if I say distance matrix,
yeah, this will have a different result. It's use the same data interpretation as
okay, that's crazy.
But isn't this that people expect that the default distance function is always Euclidean distance, and it's not?
Look, this is crazy. This result is crazy. The thing we just got out here is crazy, in my view.
I guess it depends where you come
issue
from.
there, Stephen, is it's doing the distance between the vector 1x and the vectors 1, 9.
Actually, no, it's just interpreted data as nominal. So 1x and 9 are 3 different stuff, and it's using Hamming distance, I think, in that case.
Okay, so it's just wrong, if I might say so. I mean, in the case of symbolic variables there, I don't even know. I mean, are you telling me that if I look at distance matrix of something like, you know, A, B, B, A, 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 it's going to kind of auto-select to use?
Yes. Yes. It won't use Euclidean distance in that case.
It's a very weird distance, whatever it is. What distance?
Probably edit distance. For,
well, not edit.
Well, no, it's a list, right?
Roots.
Right, you're giving it matrices. You probably should give it just.
If you just gave it vectors, it would be a bit less confusing.
Right, so this is presumably edit distance.
Yes.
That's fine. Maybe the heuristic should be that if anything is symbolic, we assume it's complex, which is what we do throughout the rest of the kernel.
Yeah, and we actually give okay, I'm confused what I'm doing here. So the correct thing would be distance matrix of 1x.
Right.
Right, and that's crazy in my opinion. In my opinion, the output from that should be, is this right?
So it should interpret these as being numerical, but just x being a
By the way, Sushma, can you please report the fact that this insertion I-beam thing is still not fixed?
Yeah.
Okay, I claim the result should be this. Do you agree with me?
That's certainly what I would have expected.
Try to have the option distance function goes to Euclidean distance.
All right, this one will work.
Well, it's a little weird. What does that mean?
I guess it's Euclidean distance isn't evaluating.
I think it takes the abs by default.
Yeah, I mean, I'm sure that it's taking the abs because it's not seeing a positive number there, but yeah, I'm not sure why the Euclidean distance isn't evaluated. Does it want to be?
Well, if you had numbers, it would evaluate. So it's just they're not evaluating, but at least this is something numeric.
But it should go enough.
No, I'm sorry. It's usually distance between distances between vectors.
Yeah, that's why.
Right. So what on earth is this? This is somehow threaded Euclidean distance down to the individual elements rather than using it as a vector distance.
Because you specified Euclidean distance, so it will use whatever you put there.
But you can say Euclidean distance of 1 and 3, and it will give you 2.
Well, that's weird. That's not as advertised here.
Well, it is, because norm works on numbers as well.
Okay.
But I agree. When there's a bunch of numeric value and just X, and symbolic stuff, it should interpret things as being numeric, and X just an unknown numeric thing.
Mm-hmm.
Yeah, you have to interpret an unknown X as complex.
Strings, but I think if you have symbolics and numbers, I think treating it numerically is probably the right way to go.
Okay, so let's zoom out for a second what the issues are, okay? First question is what distance matrix should do with symbolic input. Second thing is the complaint from Rob that norm, he wants a norm that doesn't evaluate. Right?
Yes.
However, it's very useful to have the existing norm. So there's a question of, can we come up with a named object that is the unevaluating norm?
Well, I came up at one point in our stuff of something I called vector norm.
Why is that going to help anything? Because then vector norm means that the things in it are supposed to be vectors. Is that right?
Right. It always interprets them as vector space things, so it's always a Frobenius type norm, and it never does a matrix norm, and it also just doesn't evaluate unless they're numerical vectors.
Okay, but does the name vector norm imply that it's not going to evaluate except for vectors?
Not obviously, no.
Right.
Yeah.
So you're thinking of some sort of N norm.
What do you mean N norm?
Right. You want something that doesn't evaluate unless everything is numerical. So his vector norm for list X, Y would stay unevaluated.
No, I understand that point. I'm trying to understand whether the name vector norm connotes that in a useful way.
Yeah, well, not obviously. We sort of did that with the vector, with the vector inequalities. That if any of the parts are symbolic, they
but that's because they are vector inequalities that work differently. Vectorless is fundamentally a different kind of thing.
Yes, it is different than.
Whoa, what's that?
I think you need another list.
You have to have another list in there.
So I have to have this?
Yes.
Yes.
By the way, Rob, you've got some background noise that's driving me crazy, at least. Okay. Well, I don't quite understand, the logic behind a vector norm that doesn't evaluate. That seems like a separate issue. It seems like what we're dealing with here is just a simple bug in distance matrix that when it has a symbolic variable in it, it shouldn't be doing, it should be doing that in treating it symbolically. Now, the question, obviously, for Etienne is, are there other machine learning functions which have that same issue?
I don't think it's an issue for other machine learning functions. Like when you use classify, should you treat, like, let's say you take what you put in distance matrix and you put it into classify.
Yes.
Right, with some labels.
Yes.
Should it treat X as missing? And
no.
Yeah, no. So I agree. So it should treat as a. There's two possibilities. Either it understands the data as being numeric and X is just a missing numeric value, or the data as nominal, which it does.
Yes, that's what it should do.
Yeah. So I think it's not a problem for other machine learning functions.
What about things like nearest? What do they do? I think they'll just complain, right?
Yes.
Just complains.
Yeah, it has to, whatever you give it, it has to be able to pick a distance function that gives.
Excuse me, but it didn't complain.
Well, no, it'll only complain when it actually realizes, because you might have a distance function that has a special definition for X. It complains when you try to actually evaluate.
I see.
But actually, if you take the first example,
this one here,
example of documentation, you replace one value by. Okay. No, it evaluates as well. Sorry. Yep.
Do we think it's correct that the sniff gives no error at this stage?
Yes, I think that has to be correct.
Okay. Okay. All right. So conclusion is Etienne should look at how to fix distance matrix so that it won't have that problem. Okay. And meanwhile, Rob is going to come up with some idea about vector norm, possibly. Make sense?
Yeah, I think the ship has passed. I think we found some other ways around it. I mean, because there's the whole. I mean, the big problems for modeling and the optimization stuff were norm, plus, and times.
Yeah.
And we basically found ways to work around those that seemed to be, reasonably not too complicated.
Okay. All right, fine.
One thing I should add for distance matrix business is how far do we go? So if it's just a symbol that has no definition, it's going to be pretty easy to, pretty clear what I should do. But let's say it's an image. Let's say you have some numeric value, and then you have an image in the middle.
I think there are certain raw types which will gradually expand that we natively support.
True.
So
But
in other words,
what does it mean, a symbol? Like if it's not x, but f of x, let's say. It's still interpreted as being a symbol?
Search for things being affirmatively of a type.
What do you mean?
So, check, is it a string? Is it an image? Is it a number? Et cetera, et cetera, et cetera.
Right. Otherwise, it's symbolic. Otherwise, it's a symbolic variable.
Right.
All right.
The fall-through case is it's symbolic.
That's fair.
Right. Which I think, if it falls through and it does something crazy, then somebody will report a bug. But in most cases, if it actually falls through, they probably are doing something symbolic and they'll get what they want.
I agree.
Yep.
Okay, let's go on to the next item.
Right. So you've cheated because I was going to ask you the question to tell me which of these four is an inactive operator.
How did you make the second one? By explicitly having a gray format for it?
No, the second one is not
what
inactive.
What did you do here? Is that some kind of bitmap or something?
No. I don't know. Try resizing the input cell you created. I think maybe it was just pasted in as a text cell rather than as an input cell is my guess.
Oh, okay. That would be fine. Okay, so we got a variety of colors here. So how did you get that gray one there?
That's auto times, isn't it?
That is auto times.
Okay.
Right. And so, you expressed a desire for using the cross for inactive of times, which is a pretty easy thing to do, and we can do that. But I wanted to bring up my main hesitation. The reason I didn't just do it when you said you wanted it is because, well, is this that there are?
So what's the issue?
Well, just that it's visually ambiguous, like that you can tell. Could you have told me which one was the inactive one?
If I thought about it, yeah, I probably could have told you it was this one.
Okay.
What is this one? How did you make that one? What is that?
That is the traditional form inactive one. So traditional form is always...
Yeah, blacks itself up.
Yeah, and always ambiguous. So, I mean...
So what was I asking for and what was the concern?
So what this actually does, so this is just a mock-up. If you now do %47 and let it evaluate, you'll see what the current formatting is.
Oh, that's awful.
And, I guess I don't have a problem with changing the traditional form one. My main concern is that the standard form one, like I said, it could be confused with auto times.
Okay, but that's why it's brownish.
Okay. Am I the only worry wart in this call?
I think it's a reasonable issue to raise, but I think we're okay.
Okay.
And I assume that is times the only case where we have a. I mean, you know, I would say that.
Well, power, we have to use caret because we don't have.
Yeah, a way to put anything, an indication of inactiveness.
Exactly. Yeah, so plus is fine. Power, we have to use the caret because otherwise we have nothing to draw. And I think, I'm sure there are various.
Is that right? What do we think about that? It's not obviously right to me.
That would be more work to fix. It's not.
It seems desirable to me to fix that. Very desirable, actually. I think this is a common thing people want to do, to have essentially inactive formulas.
Okay. All right. Well, we'll have to think about that case. That case is with the times case. It's just substituting the character. This case will require actual thought about how to make this happen. So that this will probably not be for 12. The times thing is, like I said, is
great. Excellent.
We can get into 12.
Hey, comment from Ethan on our live stream recommending adding NMS_lib as a method for nearest. Currently, it doesn't scale well for large indices with custom distance functions.
NMS_lib. I have never heard of NMS_lib. So,
Rob, or did Rob drop out? Oh, Rob's still here.
I'm here, but I've never heard of that library.
Why don't you look it up and let's figure out what's going on. Thank you to Ethan for suggesting this. All right, last item here, subvalues and format values. Boy, subvalues, you know, they've been around for 30 years, so we've never documented them.
Right, so yeah, so you'd need to go to DocuTools to actually see it, right? We have internal pages, which, as I say right there, it's not like we can just release them. But it's becoming a bit more obvious since we're now sort of, because of the new information, they're becoming sort of more visible, right? So, you know, at least the names are becoming more visible.
I think we should just bite the bullet. We've been using these names for 30 years and we seem to know what they mean. And I think we should just, you know, just have them become real.
Okay.
I mean, it doesn't, not for 12, it requires a little bit more thought, but I think that that's what we should go do.
Okay.
Format values, let's take a look at that. It's okay. I wonder when we created these pages. I bet these pages are 20 years old.
I'm sure they are. Actually, my guess is, my guess is probably they're 15 years old, right? I think these were probably created when the book was being
dismembered.
Put into notebooks.
Yeah. Okay.
All right. Well, it's late, so I vote we wrap. And
okay. Well, sounds good. Thanks to folks on the live stream. Thank you all here. See you all later.
Bye.
Okay,
Bye.
bye.
Yeah.